Okay, so we started a technical session today where we go over, prepping for technical interviews and coding and online assessment and even general programming, right? And so this week we gave it to ourselves to go over arrays and hashing slash list, hash tables, hash maps, and all those things. And we gave a few resources to go through. I know some of us could go through, some of us could not go through. That is fine. Today is a true test of strength. If you remember last year, we used to put ourselves in breakout rooms, and then each room had like 4 or 5 people, and then they'll go through the questions, timed, and then they would see, because you're supposed to have solved the questions before, right? We give you the questions to practice, and then you solve it, you give yourself time, then you solve it and see if you can resolve it again, and so on and so forth. We're going to do the same thing today, except today I'm not going to put you in breakout rooms. The reason being that I want to just record today's session. I realize if I put in breakout rooms, I really can't record the sessions. I think it still records just the main room, and we're unable to see the activities there. This is what we're going to do today. We give you the topics to go through arrays and hashing. Assume you couldn't even go through the topics. That's fine. You probably learned arrays and hashing already. If you probably even solved the questions before. We're going to give ourselves time. So who is not on a computer right now? We're going to time ourselves. We're going to open the questions. I'll give you the question. Then you open lit code. Strictly that question. Then you solve the question again from scratch. If you open lit code and the question has been done, you reset it. That's what I mean. Yeah. So if you learned it this time, to prove to yourself that you really learned it, because it's going to be timed. Everybody's going to be doing it in their own. So it's like we are distributed across the world as hackers trying to program together. So let me show you what we're going to do. Can everyone see my screen? Can you please see my screen?
Yeah.
Okay, good stuff. So we'll go here, and what we're going to do is this. I'm going to give the question. Oh no, we're doing the 150 like this. So you're going to click this, but don't worry, send the link, so you don't even need to go to the neat code site. If you open and it's done like this, like mine, what you do is that quickly, don't even look at the code. You reset it here to default, right? Confirm you reset it. Clean slates like this, and then we say start. Then we all try to solve it together. We're going to set a timer, which everybody will see. When the timer is up, we stop. We go to the next one. We will probably do about 3 consecutively. Then we'll pause. Then we will evaluate ourselves, right? Please, when we say stop, I would say stop and move to the next one. If you want to go on doing that one, debugging, and you're unable to do the next ones, that's on you. That is how technical interviews work. If you join an interview, you have 2 questions to solve. If you make the first question take too much time, you're unable to do the last one, you're in trouble. In fact, for some interviewers, usually the first question is just a warm-up question. So if that one tricks you, and the second one is the main question, you're able to solve it or discuss it well, you're in trouble. Are the rules clear to everyone? Are the rules clear to everyone?
Yeah.
Good. Who has any questions? Or who just joined and doesn't know what we are coming to do?
I
How do
just
you,
joined.
oh, let me share the screen again and show you. So if you open, can you see my screen? Oh, it says, can you see my screen now?
Yes, please, I can see now.
Yeah, so when you open, can you see this button here? Looks like the refresh button. Here, look, follow my mouse and
Oh,
this button.
oh yes, I can see it.
Yeah, if you click that thing, it will reset it, right? So because we don't want to cheat, we don't want you to deceive yourself. So you open the question. I send the link to the chat. You click it, you open, you come to a clean slate like this. If there's already code there, reset the code and start from scratch, and then we solve it together. We're going to solve questions consecutively. I think for now, since for start, we're going to do 3 questions. So I'll send the first one. Everybody open your laptop, start trying to solve it. When you finish it ahead of time, that's fine, right? Wait for the rest of us. I'll send the next question and the next question. For each question I send, I'll show you the time. And we're going to actually show a timer. I'm going to have a timer. That'll, I decided to use 15 minutes over, but we're going to actually use a timer, which I'll be sharing my screen with, and then you see. Don't focus too much on the timer if you are scared. Actually, let me do something quickly. Give me a second. Let me, I'm using 2 screens right now. Let me move because I don't want to copy anyone. I don't also want anyone to copy me. Okay, instead of mirroring, let's stop mirroring and, sorry, give me a second. I want to, built-in display, let's arrange, give me a second, right? I want to, okay, can you see, which of my screens can you see? What can you see on my screen? Wait, what can you please see on my screen?
You can see a menu with the display menu.
Okay,
Display
that's
to
good.
you.
That's good. Yeah, that's what I want you to see. Okay. Now let's move the clock to this. Can everyone see the clock? Wait, can people see the clock?
Yeah.
Yeah.
Okay, good stuff. Good stuff. Okay. Okay. All right, give me a second. So we're going to use, okay, is everyone ready? Can we start? Who doesn't know the rules of the game? Please, if you just join and don't know what you're doing, let me know. Just put in the chat so we just brief you quickly before we start. Because once we start, if anybody joins late, I don't know, me. Okay, so we're going to, so we gave you questions to solve. We are going to resolve those questions, right? Because you're supposed to have gone through them already. Even if you didn't, now is your time to shine, right? So we send the link to the chat. You click that link, you open, and then you solve. If you open a question on lead code and you've already solved it before, please clean up your code and start again. Everything is going to be timed, right? So for instance, this first, then our next two questions is going to take, we're going to use 5 minutes to solve the next two questions, right? So I'm going to put both questions in the chat. You solve them. If you finish ahead of time, wait for us. When the 5 minutes up, we all evaluate ourselves. If you spend too much time on one question, the other question is going to suffer, right? And it happens in interviews. Usually go to interviews, you have two questions to solve. Usually the first one is just a starter question. If you spend too much time on the starter question and you're not able to go to the main one, you're doomed. So we are preparing ourselves for that timed pressure practice. So that's basically what we're going to do now. All right, so we are starting. Let me put the first question in the chat. So give me a second. Where's my thing? Oh, sorry. Okay, so we start now. I've sent the first question. Click it and start. And I'm starting our timer. This question should take 2 minutes. Okay, I'm putting the next one in the chat too. Oh, you're using your phone. Okay. Okay, right. Let's stop. Please stop. Wait. How everybody has stopped? Have you all stopped?
Yes.
We all stopped, right? Okay.
Yes.
Good stuff. Good stuff. Yeah. Before we go on, let's do this quickly. Let's do good stuff. Good stuff before stop. Before we go on, let me launch this poll. I want to get us some things. I want to get this first. Okay. Let's provide answers for this poll before we move on to the next questions. Provide answers to this poll before we move on. I think it would be good if you can see your things. Okay. Let's provide answers to this poll. Okay. I mean, you can all see the results, right? We have a few I'm a legend. Okay. Okay, so that's like a good number actually went through. Okay. Okay, we'll get back to this later. Just realized you're being beaten a bit by time. Let's move on. We'll come to the questions later, but let's move on. We're moving to the. Oh, yes, and please, those who don't have the laptops and phones and stuff, I am so sorry. I don't know what we can do at this point. Maybe you should write them down on pen and paper, and then we'll cross check the answers. But now I want us to do a few more. 'Cause I realized these two questions were a bit straightforward, so I want us to do a few more. So we'll get back to it later. So let's move on to the next questions. Okay, next questions, we're using 5 minutes to solve both of them. The first we did were warm up. So, okay. I'm pasting the link. There's also 2 minutes. So you can start. I'm pasting both of them actually. So if you finish one next, go to the next one. I was muted. Good. I said I was so kind. I gave 5 extra seconds. Are we good? Why is no one minding me? Hello.
Yes, we are good. We are good.
Good. Are people solving the questions? I hope you are solving.
Yes, yes. So,
Oh, good, good, good. You need to feel hot. Okay, we're giving a 1 to 2 minutes break. Please don't write code. We're giving you 1 to 2 minutes break. No code, no coding. Just 1 minute break before we go on to the next set of questions. So we're giving 1 minute break. So right now, get some water to drink if you can, and stretch your body. Let me move on. Wait, is the time enough, or is too much? Should we decrease the time? Should we decrease the time? The time is too little. No, but you're supposed to have solved these questions, right? We gave you these questions in the week to solve. Yeah. So within 3 minutes, maybe the thing that may slow you down is maybe your typing. Your typing can be a bit slow. But even that, just push harder. Yeah. Or you got to think, yeah, right. We want it to be natural, be a part of you. Like you wake up from bed, you're like, two Sam. You're like, oh, two Sam. I remember the trick was I just need a dictionary to just check somewhere. Yeah. So, okay, our break is almost up. Break is almost up. Okay, so I'm sending the next question to the chat. You click the question, you open it, and then we move on. Okay, this time around, I'm going to be kind, actually. I'm going to give 5 minutes for just this one question. See, I'm being kind. So let me send a question to the chat. Okay, so we're going to have 5 minutes for this question. Hey, why is the thing not pasting? Okay, 5 minutes. I'm starting the timer, so click the question and start solving it. Are we done? Okay. Okay. Let's go on to the next one. If you decide to still use some of your time to do this one, that's going to be, this is the last one you're actually solving. If you decide to circle back to the other one, you're doomed. Wait. Oh, so we're going to the next question. And that is the last question for the programming portion. So now let's solve this. This is the last one we're doing for the programming. So I could only solve it in my mind. If you want to finish the previous one, that's fine, but just know you have less time to solve the current one. So oh, the current one. Okay, good. Okay, let's stop this. Okay, fine, good, good, good. How do we feel? Um, yeah, how do you feel? At least somebody should talk. Okay, yeah, I can see people have exercised their brains. Okay, how many questions did we solve today? Exactly right. You always have to solve the your questions. You have to solve the questions ahead of time. I know some of you open the questions, they open the practice questions. They're like, oh, I've solved this before. Move on to the next thing. But you see now, you are solving it, and we are bleeding. We are really bleeding. Okay. So now, which question do we think was tricky? Before that, I want to show you a few things. I want to show you a few Python things that I think can make your life easier. But can anybody put any question you think was tricky under reason hashing? We can't go through everything one by one because we've given you the resources to go through video recording, watch them 20 times if you have to. Group anagram. Anybody else? Any question you think? Product of array except self. Okay. Okay. Let me get my writing thing. Okay. Any question? The last one. The last one. Okay. Also, before we go through a few things, I'll also show you a few things in Python which I think can make your life easier in solving coding problems. First of all, we told you when you're practicing, right? When we give the questions to go and solve and practice, we're not asking you to go and drill yourself. We're asking you to go and sit down and learn the thing. Product of array except self, you can probably brute force it or anything, but it's a very clean solution. Nobody expects you to come out with this clean solution. So you learn it like you learn it from scratch. You learn it like you're learning physics from scratch, right? So when we ask you to go practice, please see it as going to learn. Learn it from scratch. Okay, now let me see if I can connect to this. I'm going to show you the Python stuff first, and then then I can let's see. Shit. They occurred to me as I was solving the question, as we were solving the questions together. Like some things that made me finish kind of some of mine is first and quickly. Okay, can you see my screen? Can people see
Yeah,
it? Do you see the writing part?
yeah.
Oh, okay. I just want to show a few things. Please pay attention. See, we can't hold a session to teach you cool stuff in Python, right? We can only do them as we go through these things, then they'll come up. They'll come up. So let me just open the questions we did. Okay. So first of all, if I ask you, give me a second. Okay, let me just make it very, very slick and fast. Okay, we went through hash maps and dictionaries, right? Okay, if I have a string S, right, an input S, and I want to count how many characters are in S, what is the best data structure to use? Anyone, please unmute yourself, talk, put something in the chat quickly so we go. We don't have time. I want to count the number of characters in a string S, so like A, B, C, D, right? Or something. What is it? What's the best data structure to use? Let's consider the data structure first. It's what?
Array.
Okay. Let me open the chat too. I think people also open the chat. Okay, hash maps, and everything. Yeah. So let's say we use map/arrays, right? Somebody says we can use a list, or we can also use a dictionary, right? I just want to be a bit Pythonic, right? Okay. What's the time complexity? What's the time complexity of counting? So like with this, I'm going to have something like A occurs one time, B occurs one time, C occurs one time, and D occurs one time. What's going to be the time complexity of this? O of n, good stuff, good stuff, O of n. What's going to be the space complexity? Space complexity, O of n. O of n, good. Now, this may be the case, this may also not be the case. Why? If you get a question like this in an interview, you have to consider the bounds or the type of characters that can be in your string. If they tell you your string is going to be composed of only the English characters, the alphabet, how many alphabets are there? 26. It means that no matter what, you always loop through the string. No matter what, the size of your dictionary will always be 26. So it makes it what? Constant time. So the space becomes O of 1. Does that make sense? It's actually O of 26, but that is same as what? O of 1. So when the characters you'll be considering are bound, they are fixed, it becomes constant time. Is that understood? Does that make sense to everyone?
Yeah, yeah.
Another
Yeah,
reason,
okay.
Yeah.
okay, so See, if we tell you, right, so when you get a question like this, right, where you have to maybe keep track of something, maybe record how many times the characters occurs and everything, the space is not necessarily O of n, right? O of n simply means that, as the length of the input string increases, then the space you need also what increases linearly, right? But if I give you a string s, that is always composed of the English alphabets, right? There are 26 English alphabets, right? Which means that no matter how long my string is, the space is always going to be, the dictionary will always be composed of 26 items at most, right? Like A, B, C, up to Z. Does that make sense? So the space is going to be O of 26, which implies O of 1, right? Asymptotically. Does that make sense? Another way to think about it is this. Because it is bounded, right, A up to Z, there are 26 characters, you don't even need a dictionary. You can straight away use an array or a list of size 26, right? So we know that A, right, A is going to be index 0, B is going to be index 1, C is going to be index 2, D is going to be index 3, and so on and so forth, right? So, for instance, the anagrams questions, right, the anagrams question, I know some of you were like, okay, how do I know two things are anagrams? I can sort them, I can do this, I can do this. That is a bit not efficient. I mean, sorting is logarithmic, but if you sort, still going to be 26, but one you can do it is this. If I have two strings x and t, and they're composed of only the English characters, right? I know that the English characters are just going to be 26 characters, right? So for s, I just create a list of 26 for it. This I'll create a list of 26 for it. And then I just populate it. So let's assume this string is egg. Let's say ABC. And this one is DEF, right? So let's just divide this well. So I know A is here, B is here, C is here, D, E, F, G. So for A, if I see A, I'll just increase this by 1. If I see B, I'll increase this by 1. If I see C, I'll increase this by 1. D, E, F. Let's assume that's the last three. D, E, F. After that, I just compare. Oops, I mean 1, 1, 1. I just compare. Are these two the same? If they're not, you're done. A dictionary can do it and so on. But it's just something you should know. That when the characters are bounded, it's not necessarily linear time, right? Let's go on to the next thing. The next thing also is counter. We talked about this last year, right? You realize that if you have a dictionary like this, let's just call it map, like this, and you want to populate, you want to put something in. The first time you put something in, you have to check it first, right? So you'd be like, if n in map, right? And then you put the thing in. Else, so you'd be like, maybe you want to increment how many times n occurs in map. You're like, map of n plus equals 1. Or you do, and then you do else. If it is not in, you do map of n is equal to maybe 1, right? Other people will do the get, right? Where they'll do map of n is equal to map. So this is like, if you have a dictionary and you want to, let's say, count how many times something occurs in it. The first time you see the thing, you're like, hey, is this item already in my map? If it's in, increment it by 1. If it's not in, put it in and set it to be 1, right? But there's so many lines of code. I've been telling you, in an interview, everybody has the same 30 minutes. If you spend time to write these 4 lines of code and somebody uses a simpler one, they're not going to give you more time than them. So if you learn these, these faster ways of doing things, it just saves you time. It don't spend much time on the code, but on the algorithm. So somebody too will do, so this is 1. Let's look at the 2. To somebody will do map of n is equal to map.get. They'll be like, try and get n from the map. If n is not in, right, set its value to be 0 plus 1. So here, it will first go and check the map. If it's in, it will give you the value. So let's say n is already in map and the value is 2. So this will return 2. 2 plus 1 is 3. If it's not in, to be 0 plus 1, right? The alternative way, this is also a bit long. The alternative way is this, which I prefer. When you initialize map, right, you already know that map is going to contain, let's say letters or maybe numbers, but the values, right, the values are going to be integers, right? The values are going to be integers. So if you know the type of the values, just do default dict. This is the only part you type a lot. You just do default dict. Then you pass the type of the value. Here it's just going to contain integers like this. So because you initialize your map this way, this way, let's change the colors a bit. We are too green today. Right? Because you initialize your map this way and not this way, when you're populating it, you can just do map of n plus equals 1. Right? And you don't need to do this, you don't need to do this. They achieve the same thing, right? Because what this will do is this. The default value of integers is 0. So when you do this, if n is not in, it will initialize it to 0, then it will add the 1. That is just what happens. So this is something that comes in handy. The next thing I want to show you, so we've done default dict. We did this last year, but those who don't know it, this is what default dict does. If you initialize a dictionary with default dict, just pass the type of the values inside. And it comes in cool if you do group anagrams, right? How does group anagrams work? So we know for group anagrams, we are given, a group of words. Let's use actual words. Let's say it. T. So this was the question, right? It. And let's say come. And we are like, okay, we want you to group all the anagrams. What do we know about anagrams? Those of you who went through the thing. What do we know about anagrams? What are anagrams? Anyone? What do you know about anagrams?
For a string to be an anagram,
Uh-huh.
the two strings should contain the same characters.
Right, the same characters, exactly, right? So I'm like, it, T, and it, they contain the same characters, right? But how do we translate this into an algorithm, into code? Well, we look at it, we're like, they contain the same characters, but how? One way we think about this is this. What if I sort all the characters? Well, sorting has a fixed order, right? If I sort it, A comes before first, then E, then T. If I sort T, I get this. If I sort this, I get this. If I sort this, I get C, E, M, O, right? So realize that the ones that are anagrams, right? When you sort them, you get the same things. That is cool, right? So one implementation can be this. Hey, let me get every string, every word in the strings. So when I take a word, what I'm going to sort the word. So let's call it word sorted. Now look at something. If you remember from last year, we told you mutable and non-mutable types. If you've forgotten, let me just go over it again. We said that for mutable types, mutable example is a list, right? If I create a list, like let's say n is equal to 1, 2. Lists are mutable, which means that I can just do n index 0 and set it to 5. And now when I print n, I'm going to see n to be 5, 2, right? So we have mutated, we have changed the value. Strings, you can't do that. You can't have a string. This is something people don't know. If you have a string s, called let's say come, you can't do s index 0 is equal to d. This is not possible in Python. It will give you an error. Why? You can't mutate it. You can do x index 0 to access the value of, to access c, but you can't mutate it. You can't change the value. This is something to keep in mind, but you can't change the value, right? Is that down? Do we have that in our mind? Strings are not mutable. They cannot be muted. They cannot be mutated. Okay, so let's come back to this. We know two ways to sort things. Anyone? List. If I give you a list, how do you sort them? How do you sort a list? They have the same name, just like one, but one sounds like it's in the past. How do we sort them? How do we sort list? Anyone? We have dot sort, good. We have dot sort, good. We're going to explain these two. This is how we're going to do this here. We're just going to explain things as we go on. So we have dot sort. We also have another one. What's the other one? So we have dot sort. We have another one. Sorted. Good stuff. We have sorted. Now listen to me carefully. One is a method. Forget that what that means. But we have these are their signatures. Dot sort does it in place. What does in place mean? In place means that you can only use dot sort on immutable types, right? So you can only do list dot sort. When you do list dot sort, it doesn't return anything. So like with this example I have, right, we can do n dot sort, and that will sort n in place. So assuming n was initially, n was 3, 2. If on the next line of code I do n dot sort and I print n again, n is going to be 2, 3. Because that's what dot sort works. It is a method. As you can see, you write the item here. So that's like apply dot sort to this. So to apply it to this, right? So that is how dot sort works. It mutates the thing, like it changes the thing it is being applied to. So dot sort, this is how dot sort works. And it will work on list. Why? Because lists are mutable. But dot sort cannot work on strings, right? So if I have a string, I cannot do string dot sort. Why? Because dot sort will change the thing in place, like it will mutate the original thing. But strings, you cannot mutate the original thing. That means we can't use dot sort for strings. So that comes, we are left with sorted. Now the question comes, what does sorted do? Let's look at that quickly. What sorted does is this. Sorted will take the iterable, be a list or a string. We are dealing with strings now. To take the string, then it will convert it to a list. So to do it something like this, C-O-M-E. Then it will sort it, because list can be sorted, right? Then to sort it, then you get the C-E-M-O. Then it will return it to you. So sorted returns a list. So if I have my original string to become sorted, if I call sorted on S, it's going to return a list. So you have to assign that list to some variable. Let's call it SS, sorted S, right? But this is a list. This is a list. You don't use the list, right? So note, don't forget, we are still on this question. We are still on this question. We are still here. What we want to do is that we want to, we want to take every word we take, right? We want to sort it. Every word we take, we want to sort it. then so if we could, we know when we sort it, they're the same, right? So if we had, like, let's say a dictionary where we'll use the sorted thing as a key, then if I sort you, right, and I get the same thing, I'll add it to maybe that key, right? So we want to get something like this. So when I sorted T2, I got AET. Then I'll put this also in like this, right? And so on and so forth, right? So we want to use that sorted value we get as a key in a dictionary. The next bullet point I'm going to give you, some of you probably already know it. The type of a key in a dictionary cannot be a mutable type. It can't. What do I mean? This is my dictionary. If I have a dictionary like this, these are the keys. These are the values. The only things that you can use as keys here have to be immutable. So you see, that word is still coming up. That means that you cannot change it. What do I mean by you cannot change it? Example, a list. You cannot use a list. If you don't believe me, try it and see. You can't use a list here as a key because a list is mutable and it cannot be hashed. Why do we care about it being immutable? Immutable means you cannot change it, right? Once you create it. We care about it because of hashing. If you watch the hashing video, you'd see it, that the keys get hashed, right? If the thing is mutable, we get a problem with the hashing, right? But I want the thing to be guaranteed that since the thing was, let's say ABC, right? It's not going to change. If I hash, I get this, I'm going to hash, I'm going to get the same thing, and so on and so forth, right? So when we did the sorted thing, this guy returns a list. So you can't go and put this thing as the key for your dictionary. You can't do that. Now you have to convert it to what? You have to convert it to an immutable form, like a string. The next point we are giving you. To convert a list to a string, right? Where the list contains just characters, you can use the join. So you just do this, the empty string, like this, dot join. Then you pass your list to it, like this. What this will do is that to convert it to a string, it will take all these strings inside your list and will join them together using the empty string, right? If you want to join, let's assume you have a list like this. Let's say A, B, C. And you want to join all of them, but you want to separate them with, let's say, question mark. What you do is that you do question mark like this, then dot join. Then you pass your string to it, right? Okay. So now let's come back to this. So here what we can do is that we can do sorted. So we can do sorted. Let's insert a line here. Insert space. Insert space. So we're a bit behind on time. Give me a second. We're almost done. If you're coming a lot for you, please advise yourself. I'm kidding. Insert space. Okay. So yeah. Anyone has a question? Yeah, just go ahead. Sorry, I didn't see it.
Yes.
Yeah.
Yes, put the last part. Like scroll down to the last. Yes.
Yeah.
Yes, it's good. So I want to know the condition where you can use the quotation the parenthesis question mark dot join after after the list has been sorted.
Okay, so look, so let's talk about the join again. So this is how the join works. You first write a delimiter, I almost forget how to spell this guy, delimiter, okay, dot join, then you pass a list to it. Let's say I'm in trouble, so let's say you pass a list to it. Let's consider the parts. One, this delimiter is a string. Delimiter simply means this. If I write, those of you look at Excel and CSV files, if I have, let's say, 1, 2, 3, these are the items I care about, 1, 2, and 3, but I'm delimiting, I'm separating them with a comma, right? So this comma is called a delimiter. So here I can make my delimiter be the comma. Then dot join. If I just want to merge them together like 1, 2, 3 like this, without any delimiter, I can just use the empty string, right? The empty string, dot join. Now the dot join takes an interval like a list, right? Note, the items in the list have to be strings. The items in the list have to be strings. If you just have 1, 2, 3 as integers, and you want to convert it to the string 1, 2, 3, and you just do this, it's going to give you an error because this has to be strings it can merge. If you want to know how to convert this to list, there are many ways to do it. You can use map, but we're not going to do that now. If you just want to know, you can just do map. I'm just writing tiny here. You can close your brain if you don't want to see it. You can just map string, then like your list, like nums. And this will take this, it will map over nums, convert everything to a list, and just give you something like this. 1. It's been so long I wrote Python. 2, 3. Okay, like this. But forget this. Then, so this is your delimiter, this is your join method, then you pass your list to it like this. And I will join everything, like it will put, so assume your list was like A, B, C, and let's want to delimit it by, let's say, what should we use? Let's say pipe. That's that pipe sign. That's thing like one standing on its toes. So if I do this, where the list is equal to this, I'm going to get like A, pipe B, pipe C, right? I get something like so. That's how join works, right? It takes a delimiter, then the join method, then the iterable, then to join them together, right? Okay, good stuff. Let's come back to this. So here we sorted, but when you sort, it returns to you a list, right? But we can't use a list as key in a hash map. We explained why, because lists are mutable. So let's say we have a hash map here. I called mine groups, right? So now we're going to use our default dict. Default dict. What's going to be the type of the values? Anybody? What's going to be the type? What's going to be the type? List. It's going to be a list, right? The type is a list. So in other words, this is what we want to do. I wrote it somewhere here, right? This is going to be the sorted value. That's like AET, right? And the value is going to be all the words which when sorted gave you that key, right? So you can use a list, you can use a tuple, you can use but we did list this week, so just use list. So then I will do this. Now let's find the key from this. So the key is going to be, let's just join everything together. We can do dot join. I'm just using the empty string here, right? The empty string. This is just the empty string. There's nothing here. Dot join word sorted after I sorted word, because this is a list, don't forget. Then I'll be like groups of keys dot append. Why am I doing dot append? I mean dot append because your dictionary, right, is initialized something like this. So let's say the first group and it's like this, the empty list. The moment you do this, like the empty list, right? So add an item to a list, you do dot append, right? Dot append the word. Then when you're done, all you need to do is just return. This is literally the whole code. You just return your groups. A dictionary has keys and values, right? The keys, if we do dot keys, it gives you this. It gives you like the list of the keys. Right? It gives like a list, like an iterable of the keys, like a list of the keys. In the same way, if you do dot values, but here we don't need the keys. Instead, we need dot values. So dot values, and that's the whole code, right? And I'll give you, so let me just show you this quickly. So if we had AET, right, that had whatever T, right? Then we had, let's say COP. Let's say that was cop. Let's say cop itself as a word, and so on and so forth. Let's say this was our dictionary, right? So dot keys. So let's say this was our groups. Groups dot keys will give us what? A list of AET and COP, right? And groups dot values, but look at this, look at the dot values. It's going to give you a list of what? A list of the values, but the values themselves are lists, right? So AET, T, so that's one item, to remember this item, then the next item, that is also a list, COP, right? Like that, like so, and we are done. So we just return groups of values, and that's the solution to group anagrams. Okay, we are beaten by time. So I think we had enough time to go through. This week we're supposed to go to arrays and hashing. I know some of you thought you had gone through it, but you couldn't solve the question under 5 minutes. No blasting. God willing, next week we're going to continue. The topic for God next week is stacks, queues, and decks. I want to see the code I wrote for group anagram. Okay. Give me a second. Let me pull that up. Group anagram. Why is this guy? Group anagram. Give me a second. Sorry, my thing. Okay, let's pull that up. Let me stop screen share for this. Can you see my this desktop? Wait, which of my screens can you see? Is it a timer? Wait, which of my screens can you see?
Yeah, the
The
timer.
Yes.
timer.
The timer. No, I don't want to see the timer. Okay, can you see the this one?
Yep.
Okay, so this was my solution. So this was my solution. So I used what I just explained. The other way to go about this is this. So if you read the specification, can we all see here what I've highlighted here? Can we all see this?
Yeah.
It says lowercase English characters, right? That's every word is lowercase English characters. So because of that, right, I can do something different. What I can do is for every word, right, I'm going to create. So let's say, I'm going to create, kind of like a list for the word, right? And every is going to compose of 26 characters. So like this times 26. right? So A is going to be 0, B is going to be 1, C is going to be 2, this is going to be 3, and so on and so forth, right? But there's a trick to this one. I want A to be for index 0, but you know that A in programming is not index 0. A in programming is something else, right? Like if I do, is it odd of A, right? If I just print, let's do this. Let's go to, oh, I remember I taught you, I showed you put this tool too. Python tutor. This thing is so, when I started programming, you know, I use it so much. What is this? When I say programming, you know, even when I solve questions, I don't know what it's doing. I literally just copy the code. You know, Cornell has an internal one, which is similar to this actually, and it was so helpful. I don't know why they always give us this. Let me think. Python, and it's so helpful, right? So here, what I'll do is, so you paste the code here, and you just try to visualize it. So please, if you don't know this tool, if you're new, you probably don't know this tool, please use it. Like, so for instance, let's copy this code. This is the last thing, we're almost done, okay? Those of you who are like, when are we closing? So you copy the code, paste the code here, indent it, you just have to do some cleanup, indent it, remove the self because it's no more in the class, like this. Then, you know, just call it with an example, right? So you can just copy the example. So let's just copy the first example, this one. There's even a copy here. Just click the copy. And then let's call it group anagrams, but that's a long word. Okay. Then click visualize. Oh, let's just not, clean up these things. This is still using some old Python 3 version. So just clean up these signatures. You can import them though, but it's using Python 3.6. If you use 3.1, it probably should work. Forget it. Let's just clean it. Okay. I think 3.1 is actually lowercase l. Default dict. Oh, I forgot to mention that. Thank you for catching me. Please, one reason we tell you to choose Python is because these things are already provided for you, right? Default dict is from collections. The collections must just put on your code. I remember some of the interviews I had years ago. I'm like, I'm using default dict from the collections module. I felt so proud of myself in the interviewer too, right? So just write up top here from collections, import default dict. We didn't do counter. That's something you can just look up later. Okay, so we look here, we're like, okay, so the red marker means the line next to be executed, right? So, and you look here to show you the items that were done. So here, it just be like, oh, he's imported default dict here. So that's why it's here. And then he calls group anagrams. That is a function. This is a function. He calls a function here. And this is the input to the function. So you see group anagrams here. This is the input to the function. It's a list. Then he comes here. Then at each point, you tell yourself, right? So what I tell people to do is this. The red line is the line next to execute. So you tell yourself what will happen when this line 5 is executed. So I'm like, okay, here is you create a dictionary, right? Then I click next. Then, oh, it did, right? Groups. This is the groups here. It's a dictionary. You know, default, you can even see it here. It's a dictionary. Like, you can see the dictionary, it's fine here. Then like, okay, the next thing, let's go. List. Here I create a list of 26 characters, right? So that's what should happen next inside the for loop. So you see, it creates a list of 26 characters, right? Oh, I didn't do anything with my odd A. So it's just, let's do something. Let's print the odd A. I'm sure we get for print odd A. So let's just call it index is equal to odd A. Let's move on fast. So look, in odd A is what? A is 97. 97 is so huge, right? 97 is huge, but you want the A to come here to index 0. So what we can do to our code is this, right? We want like, so let's like, if A is 97, B is 98, C is 99. You know, programmers are crazy, but not so crazy. They don't let the numbers jump around. So what I can do is this. I want A, right? Odd A means what is the number of A in programming, right? So it says it's 97, but I want it to come here. So what do? I just have to subtract minus odd A from it, right? So this is what I mean. So the index is actually the odd of the character. So what I can do here is that I'll look through every character in Word. Then the index of that character is 2 for loops, but this for loop, right, is actually very efficient compared to the sorting you're doing. It's super efficient. Hopefully next week, you actually go over time complexity. So I'll get the programming index of that character, then I'll subtract odd A from it. So look at what is happening here. If the character is A, it's going to be 97 minus 97. Can we all see it? Then to be 0. So then I end up bringing it to index 0. So yeah, I'll be like, list index this should just be plus equals 1. So this is literally what I'm doing. So if I visualize this execution, see what is happening here. Next. next C. So we create our list to be a list of 26. So look, it's a list of 26 characters. And then what we are processing now, W, as you can see here, is it. So see what will happen here. So the character is E, right? It has picked C, right? And C is E. Then it's to compute it. So the index is 4. Can you see? So it's going to put here 4. So nicely, right? Because it's A, B, C, D. E, right? E is number 4, index 4. It just puts it there nicely. Then go to the next one. That is A. EA to put it there. Then T is going to put the T there too, right? And we are done with this. So you want a key. So look, if you want a key, we can literally just, here instead of sorting is logarithmic. We'll discuss this later. But you can literally just put past this here.
Wait,
Yeah.
maybe once in 1 year or once in.
Can somebody give the right?
I don't normally eat fried yam.
Okay.
Even at the market itself, I don't normally buy it.
Person.
I just felt for it. That's all.
Okay. Good. Back on track. Good. So you can literally. So you know this. If we don't have time of explain the time complexity to you, the time complexity of this is so good. Sorting, when you sort something, is logarithmic. Time complexity of sorting is going to be like the length of the word, that is W. Let's just call it N, log N, where N is the number of characters, right, in the longest word, right, N log N. This for loop is linear, right? This for loop, the time complexity is just N, right? That's the length of the longest word, right? The word, because this for loop will execute the maximum time to, like the longest run to go is the length of the longest word, right? Now this guy is way better than this guy, right? But you see, at the end we get to the same thing here. So that is why I explained that if the input is bounded, right, it's going to be in lowercase English characters. You literally don't have to. But you see here the difference is not so much, so you probably can skip it. So yeah, okay, we are beaten by time. We'll go next week. We'll actually continue. So yeah. So what we're going to go next week, we're going to do array stacks. We're going to stack queues and yeah. So valid anagram is the same thing, and group anagrams is the same thing. Group anagrams group anagrams is just valid anagrams. You can use valid anagrams as like a helper to group anagrams, but that's going to make it inefficient because you make too many calls to the function. Probably next week. Array a part of array except self. We'll do that one next week. I don't take too much time of people, also because I have to hold one-on-ones with a couple of you. So we're going to go next week. We're doing, let me just show you now. So please solve the questions before you come. Like, solve them. I beg you. Solve them. So go next week. We're going to do, I know, if you didn't do the arrays and hashing, I'll do it if I were you. They are like imperative. We'll come back to them later, but just do them. Oh, it's actually running. Give me a second. Is that okay? So I've not deployed the website yet. No, I've been too lazy. So this is localhost. Even if you open, you won't see anything. So we did these two arrays and hashing. Next, we are going to this stacks, queues, and deck. Just a few texts to go through. I'll send it right now, and then I've not deployed it. I'm still building, so I've not deployed it yet. And then the practice questions are also going to be. You go to neat code 50, go to stack. See, it's very few, to be honest, it's so few. Just do the stack here, right? Let's do the stack here, and then you do the 2 pointers. The topic you are learning now is stacks, queues, and decks. But I want you to first do stacks. Solve the stacks questions first, just the easy and medium, skip the hard. Do as many of the mediums as you can, actually. Actually, change of mind. See, change of mind, don't worry. There's a few things I want to teach on 2 pointers before you even start doing. So you come here. For the stacks and queues, come to neat code all and go to stacks. Do all the easy ones and as many of the mediums you can do. See, stacks are so important. If I'm going to be honest with you, my first internship at Facebook, the question I got was a stack question. Actually, I got, wait, I can show you one. I got a question similar to this. Actually, this one, simplified path. Least code medium has expired, so I can show you the field really elapsed this question. It's a very popular question, to be honest. Stacks are so imperative. Like, you see how important they are. Valid parentheses. I know people go in Microsoft with this question. Valid parentheses. All right, so please solve them. So this week, the lessons, I'll share the resources after this meeting. Stacks, queues, and decks is just 5 videos, like 4 videos to go through, to be honest. Like it's just a video by Mosh, and then this website program is very, very simple. Like you can just sit in your bed, like bro, just read this. It's so simple. I told you when you read a code, try to write out this code out. Try to implement your own thing, right? Like try to implement the thing yourself too. You're like, okay, now let me implement it too, right? Try to write it like you see if some of the questions are actually design questions, like you write your own classes like this. So please try to do that. And the other resources are just videos, like very, very short videos. So please do them. And so I'll send to the chat, the Slack again, and then you do all the easies, and then the mediums go as many as you can. If you don't understand it, take a break, drink water, come back to it, try it, solve it, hands down. I wish I could show you people how I practice when it's like practice so hard, right? Like if some question tricks you for long, this is what you do. You can mark it here. You can be like, okay, I'm on you. Okay, I'm on you. Or this is what I did. I created a list here. So I'm like favorites. Favorites means these are the guys that stressed my life when I was practicing. Right? These guys stressed my life. They were tricky at some point. But then set 1, set 2, like so when I'm revising, I don't go to LeetCode, so I just come to these guys, which were very tricky, interesting questions to me. Then I'll just solve this. If I have an interview, these are the questions I solve, my own sets. I just compiled them myself. Like revision, yeah, these are like some interesting questions. So please, if a question tricks you, don't worry. Take your time, take a break, solve it, do it like you're doing physics, and on you go. We meet again, God willing, next week. You spend the first 30 minutes to do what we did today. Everybody will try to solve it. I hope you will be true to yourself. If you struggle today, be true to yourself. Go back to the thing, try it again, learn it again. You can time yourself and do it. But go next week, you can come do 5 minutes again, 3 minutes again to see what happens. Hopefully you get enough time to go through the questions people find difficulty with. If you've struggled so much with the question or the solution, let us know ahead of time so that when we come, we can start with that. Let's say this week you struggle with one question. Let us know in Slack. So when we come, God willing, next week, we will start with that. Any questions? We are done. Any questions? Any questions? Okay, no questions. Okay, I tried to record this. Yeah.
Your group and account code.
Oh yeah, the code, good stuff. The code. I can send it to which of them do you need? I'll send it to the Slack. Just make sure you ping me that I don't forget. And then I'll send it there. I forget things after this meeting. Yeah, exactly. Doing the Lord's work. Good stuff. Let's meet go next week and then we see what happens. Bye.